Okay, hi guys. For today's video, we are going to talk about trigonometric integral strategy for evaluating the integral of tangent tan mx times secant and this is n nx dx. So we have condition number 1, or let's call A. If the power of secant is even, save a factor of secant squared x and use secant squared x is equal to 1 plus tangent squared x. Let's say we have example. The integral of secant raised to 4 theta times tangent raised to 4 theta d theta. The first condition is if secant is even, which is yes, it's even, save a factor of secant squared and use secant squared x is equal to 1 plus tangent. So we will save one factor. So we have secant squared theta times secant squared theta tangent to the 4th theta d theta. So we will use secant squared x is equal to 1 plus tan x. So that means we have the integral of 1 plus tangent squared theta times tangent to the 4th theta secant squared theta d theta. Substitution rule. Let's have u is equal to tangent to express the remaining factors into tangent. The derivative of tangent theta is secant squared theta d theta. Now our d theta is equal to du over secant squared theta. So that is the integral of 1 plus u squared u to the 4th times secant squared theta times du over secant squared theta, and then we'll cancel this one. We are left with the integral of, we will distribute. This is u to the 4th plus u to the 6th du. Apply power rule. So we have 1 over 5 u to the 5 plus 1 over 7 u to the 7 plus c. Substitute back what is u. So we have 1 over 5 tangent 5 theta plus 1 over 7 tangent 7 theta plus some constant c. Now that is the final answer. The second condition is for B, we have if the power of the tangent is odd, save a factor of secant x, save a factor of we have secant x, tangent x, and use tangent squared x is equal to secant squared x minus 1 to express the remaining factors in terms of secant. So I have here, so the integral of tangent 5 theta secant 7 theta d theta. Okay, so the first condition, if tangent is odd, save a factor of secant x, tan x, and use tan squared x is equal to secant squared x minus 1. In this case, we have tangent and secant, both of them are odd, so we will remove one factor each of them. So we have tangent 4 theta, and we have secant 6 theta, and then we have secant theta tan theta d theta. Okay, and then we know that tangent squared is equal to secant squared theta minus 1. Okay, so this is secant squared theta minus 1 squared, because it says tangent 4 theta. So it's the same thing, times we have secant 6 theta times secant theta tangent theta d theta. Okay, substitution rule will let u be equal to secant theta. Now our du is secant theta tan tangent theta d theta. So our d theta is very obvious, du over secant theta tangent theta. So this means become u squared minus 1 times u to the 6th, this is squared, times secant theta tangent theta times du over secant theta tangent theta. So that means we'll cancel secant theta tan theta. So we are left with that one. That means we will distribute. We will square this one first. So that means it is u to the 4th minus 2u squared plus 1 u to the 6th du. And we will distribute u raised to 6 to everything that's in here. So that means we have the integral of u to the 10th power minus 2u to the 8th raised to 8 plus u to the 6th, that is d. So we will apply power rule to this one. So we have 1 over 11 u to raised to 11 minus 2 over 9 u raised to 9 plus 1 over 7 u raised to 7 plus some constant c. Substitute back what is u, or u is secant, so we have 1 over 11 secant 11 theta minus 2 over 9 secant raised to 9 theta plus 1 over 7 secant raised to 7 theta plus some constant c. Now that is the final answer.